Hello! Welcome back. Now that you're masters with the 7 difference and the double angle formula, we must move on. You must learn more formulas. Now, lucky news is from these formulas, this is like the right side of your formula sheet, right? And your formula sheet looks like this, right? Now, your formula sheet, this is the other half. The only ones that you're going to have to be responsible for are the double angle formulas. Yes, you're going to have to memorize the double angle formula, 7 difference formula, and also the, that's it, actually, sorry, double angle and 7 difference, okay? So those formulas you must know. As you can see, I just want to point out a couple of things. How do you not forget these? How do you derive them? Well, this one right here, it's actually derived these and all these forms of cosine double angle. Sine double angle, there's only one format, and cosine, there's 3, and tangent, there's 2, right? They're all just derived from the 7 difference formulas, okay? We'll derive them together maybe if we have time in class, but I won't show that to you on the video, all right? Now, also these power-reducing formulas, take a look. Okay, stop the video and take a look and absorb them. Take it all in. And notice some similarities, right? You can see how these are somewhat related. The sine sine squared u formula is related to the sine half u. You see how they're related? Okay, and you can see how the cosine is also related to each other. So make note of those similarities. Now, you're going to have these formulas for you during the final and also the test for this unit, okay? Now, you should be able to use a product sum formula. So you see how if you have sine u, sine v, it's this, okay? I'm going to give you all this. This is called a product sum formula. So double angle, power reducing, half angle, product sum. This is a product sum formula. You see how it goes from a product to a sum or a difference, right? Okay? And you should be able to use the sum and product formulas. You won't have a bunch of them, but you will have to be familiar with them. It's going to be really nice if you recognize that this is this or this is this, and then you can use them for your own benefit, okay? So stop the video, okay? And just try to absorb them and read over them for us before we start with the examples, okay? And proofs, when I get back, we'll actually maybe prove with you, okay? It's pretty interesting. All right, I'm going to take this away. Now let's do double angle formulas, all right? Double angle formulas. What does Ms. Chang mean by double angle formulas? I just wanted to repeat that twice because it's double angle formulas, okay? And you're going to be using double angle formulas here. You must use the double angle formulas to find the exact values of sine 2u, cosine 2u, tan 2u, given the following. Sine of u is 3/5, right? Sine of u is 3/5. And it's giving you a restrictive domain. Oh, that means it's in the which quadrant? So sketch that out for yourself correctly, right? That's what I would do. And maybe that's what you were already trying to do. Maybe that's what you were going to do anyways, okay? And then just sketch it out as approximately as possible. That's a u. And that's your hypotenuse, right? We're so used to this kind of things now, right? Now you have to write out this is the unknown value that you calculated, okay? Be careful. This one is a hypotenuse, so you know that's 4. But remember, I can twist that around a little bit. So now, why don't you find the rest of it, right? Cosine, what's cosine of u then? Cosine of u is 4/5, right? Tan u is 3/4. Write that for yourself, because you never know, you may need it. Now let's go ahead and apply our double angle. Do you see what it's saying? If sine of u, let's say u is 30 degrees, they want you to find 60 degrees. It's really what it is, okay? So don't think it's anything new. I like to write the formula, especially when I'm getting acquainted with them, pretty new, every time. Now I go, okay, sine, this is what the formula is. What's the sine of u? Oh, it's 3/5. What's cosine of u? It's 4/5. Now let's multiply, and you get 24/25. That's it, okay? Capiche? Easy, okay? Why don't you go ahead and stop the video and try cosine of 2u. Look at your formula sheet. And I know you're trying to debate, which one should I use? You're going to be able to play around with that a little bit. Listen, like you're going to know later after you've done a few, like which one is best for this situation. You're going to know. So this one is 16/25 minus a 9/25. Because I'm just taking these sines and cosines and squaring them. And you should get 7/25. All right? Now, go ahead and try tangent on your own, too. Tangent to u, the formula that you should use is what? It's probably this one, 2 tan u, all over 1 minus tan square u. I'm going to be honest with you, I don't really memorize a lot of the product sum and all the other ones that aren't as important. But the double angle and the sum and difference, you're going to use it a lot, okay? Let's plug it in. Or what else can you do for sine and cosine? Exactly, it's sine over cosine, right? So just take your 24 over 25 over 7 over 25th. And what do you get as tan 2u? You should get 24 over 7. So use your own knowledge. This is simply your sine of, right? Sine of u, and this is your cos of u. Okay? Like you can use whatever you want, okay? All right. Use your prior knowledge. Let's go on to the next example. I'm going to erase this. Hopefully you stop the video or rewind if you need it. All right. Example double, again. You must the double angle formula. Double angle formula. Okay? Now find all solutions. Again, remember how we talked about all solutions versus solutions between 0 to 2 pi versus all solutions, okay? Make sure we consider that, okay? Now, the problem is 2 cosine of x plus sine 2x equals 0. Notice that this guy is going to require some sort of double angle stuff, okay? So let's rewrite cosine of x. Why don't you take a stab at it right now on your own and then come back to the video if you feel like you're stuck, okay? The sine of 2x is going to be 2 sine x cosine of x equals 0. We're solving, okay? And what's the trick in solving, right? We have two things, but we have some common factors. To pull that out, maybe? Okay, 1 plus sine of x equals 0. Now we got into factors. This is something that we're used to from 5.3 way back when. And you plug this in, 2 cosine of x has to equal 0. So when is cosine of x equal to 0, you ask? You say x equals pi over 2 and x equals 3 pi over 2. But this occurs how often? It occurs every 2 pi and n times indefinitely, right? And this is exactly the same. And remember, n is an integer, okay? Okay, n is an integer, but we know that it repeats every 2 pi. Let's go on to the next case, next factor. 1 plus sine x is equal to 0, so sine of x is equal to negative 1. When is sine of x negative 1? You're right, it's 3 pi over 2, but it's all real solutions. How often does it happen? Every 2 pi indefinitely. So we have to write that in there, okay? All right, let's move on to power reducing, okay? We're going to give you a little taste of every type of formula that you're going to have to use, okay? The double angle, as you see, it's pretty simple, no different than sum and difference and all your other formulas you've been using, okay? Now, I want you to write for me. This one's going to take a while, okay? Sine to the 4th x as a sum. Right now, this is a power, right? So we're going to reduce that power of first powers, of cosines, of multiple angles. Woo! This one sounds a little bit more interesting, right? Sine to the 4th of x as a sum of first powers. Right now, it's a power. We're going to reduce it, but we're going to only have cosines in our answer. So I'm going to be honest with you, this one's going to take a while, okay? All right, so now, well, let's first do this. Let's use what we kind of know already, right? So sine of 4th to the x is equal to sine squared x squared. You agree with that? Yeah, let me hear it. Okay, great, okay? Now let's apply our power reducing formula, right? Take a look at your formula sheet. Think about which formula you're going to use, right? You're looking at it, which one am I going to use, right? You're like, okay, I see that sine square u is equal to 1 minus cosine 2u all over 2. Now, this one I want you to work with someone because you may have trouble understanding the algebraic portion of it. So I do want you to understand the algebra, okay? So now, this guy, you see how that's that. So let's rewrite that using that. And look, we've already achieved our first goal. Our first goal was to write it all in terms of cosine, right? And it is in terms of cosine. Yay, okay? All right, now you're like, okay, I'm going to apply that somehow. I'm going to apply that. But what else are you going to need here, right? Let's let u equal 2x. That might make it easier for us, okay? Just understand that, because then that's our u right there, okay? Okay, now, let's do another one. Let's go again. Next step is this. I'm going to explain to you once I write it. 1 minus 2 cosine 2x plus cosine square 2x. Where did that come from? oh, we just squared this, right? All we did was square this quantity here to get this, okay? And I just pulled out the 1/4 because it's 1 minus 2 cosine 2x over 2 squared. So it's 1/4 of the outside, okay? All right, now, oh my gosh, but you can see also here, right? That's a double angle here, and that's something here. What are we going to do, okay? We're going to reduce the power again for this sucker here. We're going to reduce the power again here. Now, cosine power reducing is what? Cosine squared u. Look at your formula sheet. Okay, your formula sheet. And your formula sheet says cosine 2u is 1 plus cosine 2u all over 2. Okay? Okay, so cosine, sine, and tangent of power reducing are all in terms of cosine. Exactly what we wanted to achieve, okay? So we're going to do this. 1/4, right? And okay, let's deal with this guy first, okay? Let's deal with this guy. What does this guy become? 1 minus 2 cosine 2x. Leave that guy alone. This guy becomes 1 plus cosine of 4x. Do you understand why that's 4x? Because this was a 2x, but it's 2u. Remember, our u is 2x, so we multiply by 2. That's going to be 4x. Stop the video and ask a neighbor who looks the most trustworthy to understand how this happened, okay? Stop the video. I know that's going to be the tricky part, okay? Then that equals 1/4 minus, I'm going to multiply it all in, okay? 1/2 cos 2x plus, I'm going to square this too, okay? I'm going to, not square it, I'm going to actually take the 1/2 and multiply by 1/4, which is 1/8, right? I'm going to separate this fraction. You'll see why, okay? And then you get 1/8 cosine 4x. Okay? This whole thing, because I just distributed this 1/4 to everything here. But you remember, this is actually 2 terms, right? Okay, this is 2 terms. The half, and then the 1/2 cosine 4x, and that's how this becomes that. Now, I just simplify this, and I pull out a 1/8, because all these guys have 1/8. If you don't understand the calculation part, it's not a big deal. Just pull out, think about all the common factors of each individual term. It's 1/8. Then you'll see you get 3 minus 4 cosine 2x plus cosine 4x. Stop the video. I know this is going to be the tricky part for you guys, okay? So this is your final solution, okay? All right, what I want you guys to do now is stop the video and try this one. I want you to now take cosine 4 to the x, okay? Cosine 4 to the x, and then use the power reducing formula to rewrite cosine 4 to the x as sum of first powers of cosines, or of sines, okay? Using cosine again, not sine, okay? Now, look, notice how we did it here. Follow the same kind of steps, okay? I'm going to stop the video now, and then on part 2 of this video, you'll see the answers to that, okay? But try it right now quietly. This is number 25 from your homework.